So we start with derivatives. Earlier we defined the slope of a curve at a point as the limit of secant slope. This limit, called the derivative, measures the rate at which a function changes and is one of the most important ideas in calculus. Derivatives are used widely in science, economics, medicine, computer science to calculate velocity and acceleration, to explain the behavior of machinery, to estimate the drop in water levels as water is pumped out of a tank, to predict the consequences of making errors in measurement, etc. etc. Finding derivatives by evaluating limits can be lengthy and difficult. In this chapter, we will develop techniques to make calculating derivatives easier. Okay, so that was the motivation.
Yes.
Derivatives are also used in finance, stock market, you name it. So we come to the basic definition. The derivative of a function. Now pay a lot of attention to this chapter, not just for the math, but also for your physics and chemistry. We defined the slope of a curve y equal to f of x at the point x equal to x0 to be m equal to limit h tending to 0 f of x plus h, x0 plus h minus f of x0 over h. We call this limit when it exists, meaning when it is finite. So when it exists means when this value is a finite number. The derivative at x0 Now we consider the derivative of the function at each point in its domain, and hence the definition follows. Definition: the derivative of a function f with respect to the variable x is the function f prime whose value at x is provided the limit exists. Once again, provided the limit exists. We call finding the derivative in this way finding the derivative from first principles or from basic definition or from scratch, to use a fancy word. Please take all the notes. The domain of f prime rather, that is the set of points in the domain of f for which the limit exists may be smaller than the domain of f. If f prime of x exists, we say that f has a derivative or is differentiable at x. Next, look at some notation in literature. Notation. There are many ways to denote derivative or derivatives. One is, so given the function y equal to f of x, we want to denote its derivative. So one way is y, it is called y prime, then dy by dx, dy by dx, then df by dx. So this is df by dx. This is how we read and speak. Then another way is d by dx of f of x. D by dx of f of x. It is also denoted this way, dx of f, and sometimes y with a dot on it. It is read as, of course, y dot. Then one more note which you should write down and remember. We also read dy by dx as the derivative of y with respect to, WRT means different with respect to x. Okay, x is the variable, x is the independent variable, y depends on x, and df by dx and d by dx f of x as the derivative of f with respect to x. Okay, did you take notes?
Yes.
We immediately jump to calculations. Calculating derivatives from the definition or first principles or from first principles or from scratch. The process of calculating derivatives is called differentiation. So example 1, differentiate B. This is part A of the question. B, where does the curve y equal to f of x have slope -1? So solution part A, by definition f prime of x or f of x, derivative of f is limit h tending to 0 f of x plus h minus f of x over h equal to limit h tending to 0. Hello, are you with me?
Yes, sir.
Okay. So on f of x plus h, see, when f of x itself is equal to x over x minus 1, what does f of x plus h mean?
Sir?
This x has now become x plus h, so wherever there was x, replace it with x plus h. So now there are fractions to be subtracted in the numerator. This equals one by limit h tending to 0, 1 by h So this then equals limit h tending to 0. On simplification, h minus h, hence x plus h minus 1, hence x minus 1. So as h tends to 0, h is very near 0, but h not equal to 0, so we can divide both numerator and denominator by h. So it vanishes, giving us limit h tending to 0 minus 1 divided by x plus h minus 1 times x minus 1. Simply substitute h equal to 0 and you will get the limit as minus 1 over x minus 1 whole squared. That's the answer. Derivative of the given function f of x is minus 1 over x minus 1 whole squared. Is it clear?
Yes.
So part B is the slope of y equal to f of x will be minus 1 provided minus 1 over x minus 1 whole squared equals minus 1 implies x equal to 2 or x equal to 0 on solving the quadratic equation. Okay, did you take notes?
Yes.
Next example. Example 2, part A. Find the derivative of y equal to root x for x greater than 0. B. Find the tangent line. Anubhav, in part A, why do we require x greater than 0?
Sir?
In part A, why do we require x greater than 0?
See, because if x is not greater than 0, then it's a negative number which results in complex numbers.
Yes, at x equal to. Good. So solution to part A, by definition, derivative of f prime of x is equal to limit h tending to 0 f of x plus h minus f of x over h equals limit h tending to 0. Now understand this, what is going on with, what is the difference between f of x and f of x plus h. See, if y equal to f of x equal to square root x, f of x plus h is square root of x plus h. Why? Because now this x has become x plus h. So wherever there was x on the right hand side, replace it with square root x plus h. So now we get limit of x plus h minus square root x over h. See, if we simply substitute x equal to 0, h equal to 0, we will get 0 over 0. So that means there is something fishy. We have to resort to calculus. So we will rationalize the numerator. So this is, the numerator is a plus b times c minus b, so it becomes a squared minus b squared. So now the numerator is x cancels, h over h cancels, as h tends to 0. H is very near 0 but not equal to 0, so we can divide numerator and denominator by h. It goes away, it gets cancelled, and we get, I'm writing with another font on the left hand side of the board, limit h tending to 0, 1 over square root x plus h plus square root x equals 1 over square root x plus x, substituting h equal to 0. So the derivative is 1 over 2x, that is the answer. There are several problems in your NCERT textbook of this type, that is why I am illustrating these. Part B of the same question is find the tangent line to the curve y equal to square root x at x equal to 4. So solution is very easy. Find the tangent line. So we have to find the slope. Slope of tangent is equal to m equal to derivative by definition or by geometric interpretation of derivative equals 1 over 2 root x at which value of x? At x equal to 4. So m becomes equal to 1 over 2 root 4 equal to 1 upon 4. Now we have to find the tangent line. So we have to find equation of tangent line. When x equal to 4, y is equal to square root x equal to 2. So the line passes through the point P to 4. So P is like x1 y1. So the equation of the line becomes y minus y1 equals m times x minus x1. Remember from our 10th standard days?
Yes, sir.
Therefore y minus 4 equals m. What is m? 1 by 4 times x minus 2. Just simplify it. So we will get 4y minus 16 equals x minus 2. So that is the equation is x minus 4y plus 14 equal to 0, and that's the answer. equation of the tangent line. Okay.
Yes, sir.
Next we come to some level of detail. The topic is differentiability or differentiable on an interval rather than at a point only, right? A function y equal to f of x is differentiable. A function y equal to f of x is differentiable on an open interval which could be finite or infinite. Finite or infinite if it has a derivative. If it has a derivative at each point of the interval, at each point of the interval, it is differentiable on a closed interval. It is differentiable on a closed interval closed interval is this, right? A less than or equal to x less than or equal to b. This is a closed interval. If it is differentiable, if it is differentiable on the interior, that is the open interval AB, and if the limits and so and means these condition has to be satisfied, rather these conditions are also have to be satisfied. Limit h tending to 0 plus f of a plus h minus f of a over h. So this is right hand derivative at a. That means h approaches a from the right hand side, from greater than a. That is right hand derivative. Limit h tending to 0 minus f of b plus h minus f of b over h. So this means derivative from the left hand side and approaching b, left hand derivative at b exists if both this limit exists at the end points Okay, did you take notes?
Yes, sir.
Okay, we continue this further. Some comments are in order. Right hand and left hand derivatives. Right hand and left hand derivatives. May be defined at any point of a function's domain. At any point of a function's domain. The usual relation between one-sided and two-sided limits holds for these derivatives. Holds for these derivatives also, not just derivatives. Hence, a function has a derivative at a point if and only if if means if and only if it has a left hand derivative and right hand derivative at that point, and also these one-sided derivatives need to be equal. I'll show you the diagram.
So I have one more picture after this.
Okay, so it will take some time. We will continue later. Okay.
Yes.
Okay. Thank you. Bye bye.